Alright, so in this video we're going to be looking at trig bearings. So this is another layer to our trig questions where we're going to have to do a bit of angle manipulation in order to help form our triangle for the questions. So I've got 3 for us to go through. I'm just going to jump straight in order to try and make sure this video doesn't get too long. So 2 boats leave a port. Boat A leaves on a bearing of 102 degrees for 5 kilometers and boat B heads directly south for 9 kilometers. What is the distance between the 2 boats? So I'm being asked to find out this dotted line here. And the moment I draw that dotted line, I can instantly see I've got a triangle there. So it's going to be one of my trig questions and I need to start figuring it out which of my formulas I'm going to use. To help me, I need to start putting in some of the information from that written part of the question. So key things to look out for, this bearing of 102 degrees for 5 kilometers for boat A. So that means this distance here is 5 kilometers. And remember, bearings go from the northern line in a clockwise direction. So that's going to come round in a clockwise direction for 102 degrees. And then boat B heads directly south for 9 kilometers. So this distance here is going to be 9 kilometers. And because we know that boat B is directly south, that means this here is a straight line. So this will be a total of 180 degrees there. And so we're being asked to find the distance between the 2 boats. So looking at what I have one side, 2 side, and I'm being asked to find the 3rd side. That means it is my cosine rule, specifically that a squared equals b squared plus c squared minus 2bc cos a. So this length is going to be my a, which means up by the port, that's going to be my capital A. Because remember, A is the subject here, so that needs to be where my unknown's at. So then all I'm going to do is just quickly change boat A to a C, and my boat B can just stay as B there. Now, before I do any substitution, I've got this issue of this cos A right now. And that A is specifically the angle that's inside the triangle. So don't fall in the trap of using that 102. However, we can make use of it in order to find out what that angle is going to be. Because remember, this is a straight line. And angles on a straight line add up to 180 degrees. So I'm going to have 180 take away that 102. And therefore, that means this angle in here is going to be 78 degrees. So then substituting all of that into my formula. So it's going to be 5 squared plus 9 squared minus 2 times 5 times 9 times that cos 78. And putting all of that into my calculator. And that is just going to come out as 87.287 and so forth. But I need to find out A, so I've got to square root that. And remember, I can just do square root and press the answer button so I don't have to write that whole thing out. And that is just going to come out as 9.3428 and so forth. And if I was to round it to 2 decimal places, that would just be 9.34. And I'm going to have kilometers. Okay, so next one, I've got on a golf course, the tee is a distance of 130 metres due west from the pin. On his first shot, Bruce hits the ball 100 metres. On his second shot, he hits the ball 35 metres and gets it in the hole. What bearing A did he hit his first stroke? So we want to find out what this angle in here is going to be. Now, to start off with, we've got most of our information in this sort of written part down, but the only thing we haven't got on that diagram, and it's the key thing that's going to help us with this question, is this due west. Whenever you see due west, due east, that is an important bit of information, and that means at this angle here, from my starting point to my end, that's at 90 degrees. That's at a right angle. So given that I know that this is at a right angle, in order to find out this angle here, if I can find out what the angle inside the triangle is going to be, I can take that away from 90 degrees to find that angle A. So that's my game plan. I want to figure out what this angle in here is going to be, and then I can take it away from 90 degrees. So to start off with, I need to identify my formula. Well, I've got 1, 2, 3 sides given, so that means it's my cosine formula, except this time, because I'm finding the angle, it's the cos A equals b squared plus c squared minus a squared all over 2bc. So A needs to be where my unknown is. So that'll be my lowercase a, and the b and the c, doesn't matter what way around I put it. So then substituting into that formula, I'm going to have 130 squared plus 100 squared minus the 35 squared all over 2 times the 130 times the 100. And then I want to put all of that into my calculator so it can simplify that fraction for me. And so that is just going to come out as 79 over 80. So then A is just going to be the cos inverse of that. And again, I can use that answer button so I don't have to type that out. And that comes out as 9.0687 and so forth. And that is just going to be, to 2 decimal places, 9.07 degrees. So then I know what this angle in here is going to be, that 9.07, but I want to find out that angle A outside the triangle. So like I said, if we take that 90 degrees because of that right angle due to the fact it's due west, take away the 9.07, that is going to give me 80.93 degrees. But because it is bearings, I have it as 0.93 degrees. Okay, so that's that one there. And then the last question here. So this one got a little bit of information to read through. So we have a ship's mate is planning the course for a voyage, which is shown below. He knows he has to sail from port A to port B on a bearing of 77 degrees, and from there to port C on a bearing of 117 degrees for 1,200 kilometers. In order to return to port A, the ship has to sail on a bearing of 285 degrees. Calculate how far the ship will have to sail to return to its starting point AC. So in this question here, this whole bit at the top up here, all that information is in the diagram, so we don't have to worry about that. And so what we're trying to figure out today is the distance. Oh, forgot to rewrite my C in. Distance from A to C. So it's this distance here. So to begin with, what I'm going to do is that I'm just going to try and figure out as many potential angles as possible. Because looking at this, it's not really helping me identify any of my formulas. So that's what I am going to do. So to start off with, one really key important thing with these types of questions is if you take the northern line and extend it a little, you can sometimes get a little bit more information from it. Now, I can't really do much here because I've got these two splitting lines coming off with the northern line. However, here, where this line splits down, I know the total angle on this line is going to be 180 degrees because it's angles on a straight line. So in order to find out this angle in here, all I have to do is 180 take away that 117 degrees. And doing 180 take away the 117, that is just going to give me 63 degrees. So that's one angle that I've managed to find out. So the next thing I'm going to do is looking around. There's nothing else where I can just do a simple subtraction because over here I've got similar issues where I've got multiple lines sticking out there. So I can't really do making use of 180 or even 360 around this point. So I'm going to start using one of my other key bits of angle knowledge. And the one you must always try and remember to make use of is your Z angles. And remember, Z angles inside the corner, they are the exact same value. The angle is the exact same. So I'm going to go about trying to see what Z angles I can spot in entire angles where I'm missing some information. And I'm going to start here because this is the middle one, so everything's going to kind of relate to the middle here. And if I follow this line down and go up the northern line, because I'm working from my northern lines, they're parallel, this 77 degrees is going to be the same up here. So up here I've got 77 degrees. And suddenly I'm able to find out this total angle. 77 plus the 63, that is just going to give me 140 degrees. Okay, so I've got that information there done. So what else can I find? So I'm going to try and do another Z angle. This time, let's see what occurs if I go in the other direction. So if I go down here, then my line's going to come up this way. So this 63 is going to be the same as this 63 in here. So that's going to be 63 degrees in there. And now that I've got this part here, because I also know this section here, I can find out what this last angle inside this triangle is going to be around this point. Because remember, angles around a point all add up to 360 degrees. So if I do 360, take away the other two angles added together, that is just going to come out to, so 360 take away, that'll be 348. That's come out to 12 degrees. So inside the triangle here, I've got 12 degrees. And I know what two of my angles are, so at this point I can easily find out what my last angle inside the triangle is going to be by adding the other two up and taking that away from 180. Which is just going to be 28 degrees. So I've now got all my angles inside the triangle. I've got all the information I will need for any sort of trig formula that I might want to do. So now I need to try and figure out which of my formulas I'm going to use. So looking at this, I haven't got anything saying the word area, so it's not my area one. I know one side, I'm trying to find the second side, so that means it's not going to be my cosine rule. So therefore, that leaves behind my sine rule. So I am just going to rub this out to give myself a bit of space. So I'm going to be using my sine rule, and I'm finding a side, so it's the A over sine A 1. So labeling my sides, that's my lowercase a, lowercase b, and lowercase c. My capital A, my lowercase a is that 1,200 here. So I'm going to give that a tick. My capital A is this 28 over here. So I'm going to give that a tick. My lowercase b I want to find out. And my capital B is this 140 degrees here. So give that a tick. Lowercase c I don't have any information for. My capital C I do know, which is at 12, but that's the only one where I don't have two ticks, so I'm crossing it out. So then substituting everything into the formula that I do know. So A is that 1,200, capital A is 140, capital B lowercase b I don't know, but my capital B is that 100, getting ahead of myself. My capital A is 28. There we are. And my capital B is the 140. God, I managed to spot that there. Okay, so B is the thing I want. So I write B equals, multiply across that diagonal. So 1,200 times sine 140, and then divide by the last thing remaining. So sine 28. So then putting all of that into my calculator, that gives me an answer of 1,643.007 and so forth. So 2 decimal places, that would be 1,643.01 kilometers. So these ones in particular are quite tricky, where you are having to do quite a fair bit of angle manipulation. But like I said, the moment you extend these northern lines, it suddenly paints a much clearer picture, especially when it comes to the Z angles that occur on these. But the best way to do it is to find out as many angles as possible. You may not find every angle in the triangle. Sometimes the work you might be doing will only actually lead to one angle inside. However, do as many as possible, then see, right from here, can I use one of my formulas? I hope that has been all right. I know I've kind of talked through it a bit quick, but hopefully that was okay. And if you have any questions, let me know. But otherwise, good luck with the work.